And now for a real check of of how good your modeling skills are. We've been asked to find h, the height where the ball started, its trajectory up, its throw up. Okay. Remember, it wasn't on the ground; it was h meters above the ground, and we need to find what h is. Okay. Note, I'll put st here. Why have I put displacement total? Because I think to model this properly, the best thing is to view it as, well, you have the first section of the displacement where it goes up to a velocity of 0, then the second bit where it's coming down and it gets back to the position it started from, and then the third bit, which is where it travels a distance of h meters, okay, coming down to the ground. We had the initial speed u. That was in the upward direction, so we will be working from that upward direction. We're dealing with vectors. We are dealing direction matters. I think that's the key part of the message for doing this model right. So we know when it got to the ground, we know this already, 6.5 meters per second squared was the velocity, was the speed, so the velocity is minus 6.45 meters per second squared. So it started off at 0.9. When it finished, it was traveling at minus 6.45. Okay, that took 75 seconds, so we know t is 75.75. What am I saying? 75 seconds. That's a ball in slow motion, 4K video in slow motion. Okay, 0.75 seconds. So in a split, you didn't really see it happen. It just happened. That's real quick. And acceleration due to gravity minus 9.8. Minus 9.8 is the acceleration due to gravity. Let's draw that line. Let's focus for a moment P. That point P when the ball goes up and it comes back down. We know from the previous question from part B that the distance it traveled when it went up was 0.041 meters. And it got up there. And then that means that when it came back down to be level with P again, to back where it started, it also traveled 0.041 meters. Okay, that's the distance it traveled. But displacement is distance in a given direction. That changes a lot. So if I call the first leg of the displacement S1, it's going to be 0.041, but the second bit has to be negative 0.041. Because it's going in the opposite direction. What does that mean? That actually means for the first two legs, from the time that ball goes up and it comes back down, its displacement is actually 0. It hasn't, think about it, it hasn't gone anywhere. It came back right where it was. We're back to the beginning. We're back to 0. And then there's the third leg, which is not h, because if I view h as not distance traveled but displacement, it's in the upward direction. That means that coming down, when I travel those h meters, my displacement is minus h. So that means the total displacement, st, well, s1 cancels out with s2, so the total displacement is just the third leg. It's actually just minus h. Whoa. Sink that in, make sure you're comfortable with that, because once you're comfortable with that, that's it, we're sorted. This is once you get this model right, this is one of the beautiful questions where you have no less than 4 Suvat equations that you can use to get your answer. Because you have all the variables, the u, v, a, and t, you have all of them. You just want to, so anything that has s in it, you can use. And there's 4 of them with s. I'll just use the first one. If you use a different one, we all should end up at the same place. When you do your substitution, these are the values. This is what it should look like. And then when you simplify that, work it down, you'll get minus h is minus 2.1. Remember s, the total displacement is minus h. So minus h is minus 2.1. Sorted. Yeah, that's it. You could have minus 2.08. That's perfectly fine. Remember that rule. If you're using a G, 9.8, you give your answer to 2 or 3 significant figures. So 2.08 is also, in terms of accuracy, you would get marks for that as well. So M1 for a right method using a Suvat, one of the appropriate Suvat formulas, and A1 for getting the right answer 2.1 or 2.08. I think this was a good one. That's why I said I enjoyed it. This was fun. Hope you enjoyed it as well. Hope you got it right. If you didn't, make your corrections as appropriate and commit these concepts to memory so next time you get one of these, maybe on your exam day, you can have the success that you want.